Okay, so practice exam 1, step 4 note page. So this is a calculator problem. So the rate at which raw sewage enters a treatment tank is given by this gallons per hour. Okay, so this is the rate of change. So this is the rate at which the sewage is entering the tank. Okay, so this many gallons per hour. For 0 to 4 hours. Treated sewage is removed from the tank at the constant rate of 645 gallons per hour. Okay, so there's another rate. Oh, and right away, guys, you should be thinking rate in, rate out. Okay, so rate in, and then this is rate out. Okay, rate in, rate out. And so if we want the rate of change of the sewage in the tank, it's going to be rate in minus rate out. Yeah. Okay, so, and I think just about all of you recognize that, but some of you jumped the gun. You did rate in minus rate out a little bit too early. So that's why I wasn't able to give you any points, but I was really pleased that you noticed that. Okay, the treatment tank is empty at t equals 0. All right, so how many gallons of sewage enter the treatment tank during this time interval? Round your answer to the nearest gallon. Okay, so guys, you have to ask yourself, like, what this means. Like, and I noticed that they're asking for a total. All right, so they want total sewage that entered the tank. And something that I am just making this observation just this year, whenever they want a total, it is like out of these three things, limit, derivative, antiderivative, or an integral, it's always this one. All right, it's this one down here. That is when you hear total. Okay, total anything, it's this. Because to get the total something, if you know something is changing at a certain rate, to get the total amount that it had changed, you do the integral of the rate of change. You do the integral of the derivative. This is what's called the net change theorem. And this theorem is, let me find it. This theorem is here. Okay, exam topics to look for, the net change theorem. Alrighty, so this is 14. Okay, so the net change, the total change in F over an interval is given by that. Okay, notice you put the rate in there. So we're going to use the net change theorem, which says that it's going to be the integral from 0 to 4 of e of t dt. Alrighty, and then we're just going to plug that into our calculator. So I'm going to go to my calculator. It needs to be in radians. And then I go math 9. And then it's this rate. They want how many gallons of sewage? How many gallons of sewage enter the treatment tank? Okay, so enter. So we don't care about the rate out. We only care about the rate in for this one. So it's from 0 to 4. And then 850 plus 715 cosine. And then, guys, if you do this thing, if you hit alpha and then y equals, you could do a fraction like that. That's what the younger kids always do. Oopsie. And then I have to close those parentheses. Okay, and then they say to the nearest gallon. So 3981 gallons. Now, a couple of you got this answer, but you didn't show the integral, so you didn't get full points. So this is 2 points right there. Integral answer. You can all do that. You can absolutely do that after we've practiced more. So there's part A. Now part B. For the same interval, at what time is the amount of sewage in the treatment tank greatest? To the nearest gallon, what is the maximum amount of sewage in the tank? Justify your answer. All right. So, all right, this word, all right, so they said greatest, they said maximum. So when you hear these words, greatest, maximum, limit, derivative, antiderivative, we're going to need to take the derivative, or we're going to need to use the derivative anyway. Okay, we will need to use it. And we're going to have to use it for the candidates test. So, anyway, okay, first let's come up with the derivative, with the rate function. Okay, so this is for part B. Did they use A anywhere? I'll say A. Let A of T be the amount of sewage in the tank. Okay. Then A prime of T. Okay, so this is the rate of change in the amount of sewage in the tank. It's going to be rate in minus rate out. Okay, which is equal to 850 minus, okay? All right, so that's the rate of change there. Okay, now, they're asking, since they're asking for, you know, this word greatest and then maximum, so they want the maximum, and since it is on a closed interval, it's the absolute maximum. If it were on like an open interval, it would just be a relative maximum, but if it's on a closed interval, that's the absolute maximum, so we need the candidates test. All right, so... All right, so, okay, so anyway, we need, so let's do it down here. So candidates, okay, and I'm leaving some space because I'm going to write something else. So candidates test. So we're going to have T, and then A of T, all right? Now the interval 0 to 4, all right, those are the endpoints. And then in between, we need where, okay, so these would be the critical numbers. So A prime is equal to 0, or A prime is undefined. Okay, so, yeah, where A prime is equal to 0, or, okay, so this is A prime right here. So, so we'll go like this. A prime. A prime of T equals 0. Then 850 plus 715 cosine equals 0. Then, okay, so this is a calculator section. So I'm going to go to my calculator and I'm going to figure out where this is equal to 0. So I'm going to graph it. Okay, y equals... And you could combine like terms here, guys. So 850 plus 750. And guys, if you're just watching me, that's, you know, that's fine. But I think it'd be even more powerful if you like were doing this along with me or trying to go ahead of me would be even better. Okay, so let me graph this. I don't think this is a good window. No, it's awful. Window. All right, let me go zoom. Zoom standard will be 10 by 10. Oh my gosh. What? That is ridiculous. Oh, okay. But it's only from 0 to 4. Aha. So I'm looking for, that's good news. All right, so I'm looking for 0 to 4. So window, x min 0, x max 4. Okay, so it looks like I'm going to have these two critical numbers. And let me see, let me go to the window and go negative 0.5, just see if it makes it look a little bit better. I'd like it more slanted. I doubt it. No, it didn't help. Okay, never mind. So I'm going to go, so I got to find these. So I'm going to go math. Yeah, math. No. How does it go? Can't believe I forgot. Oh, calc. I go up there. So I go second trace for calc. And then I'm going to go to the 0. Hit 0. So I'm trying to figure out these zeros. Okay, so left bound. So since the y value is high, I know I'm above the x-axis, even though I can't even see what I'm doing. Okay, and then it went below the x-axis. And the x is like 2.312. Okay, so I think, all right. So like there, I'm somewhere, I think, above this. So I hit enter. And now I've got to go below it. So I hit right till it's negative. Okay, so there's that. All right, and now, if I go second quit, and I hit X, there is that answer. Okay, that's the answer that my calculator just gave me. So I'm going to store that for later. So I'm going to hit store. So store, and I'll store it as A. All right, so I'm going to store that as A. So here's one value. Then T, so T equals 2.30934 ... and then I'll store this as A, all right? And then we're going to have another value in just a minute. So I got to go back to my graph. And now I've got to get this value here. So again, I go second calc. And I'm going to go to the 0 thing. All right. So I'm just going right. All right, I'm just watching for when it gets positive again. Okay, so now it's positive. The y values are positive again. Like, where? Okay, so I think I'm like somewhere up here. But I want to start left bound. So now I'm below the x-axis, hit enter. Now I'm above. Okay, so then this x value. So second quit, hit X in your home screen, and there it is. So we'll store this as B. So store B. Okay. So then here we have T equals 3.55906 ... And I'll store that as B. Okay. So those are ready. So the critical values, so we're going to have A, so this will be A, and that will be B. Darn it, I already used A for that. Ugh, that actually kind of is a problem. Let me do this as C. Let me do this as C because I already used A. All right, so just to fix it, I'll just hit A again, hit enter, there it is, and then I'll store that as C. Okay, so C. It's out of alphabetical order, but. Okay, guys. Now, for the candidates test over here, we need the function a of t to get the outputs. Well, if you want a of t, so maybe like off to the side here. We'll go off to the side here. A of t is going to equal limit, derivative, or antiderivative. Well, I already know a prime. Okay, so this is a prime. So what I want is I want the antiderivative. And we're going to use an integral to get it. So what we're going to do is, and I'm sorry I'm going so slow, guys. I'm just trying to do a good job. You could always speed me up if I'm going too slow. Okay. All right, so this is going to be our best bud, this formula, when we're done with our training. So the antiderivative with an integral formula. So we're going to use this right here. Okay. So A of t is equal to, all right, so the treatment tank is empty at t equals 0. All right, so this will be like, so that's what we know. So we want a of 0 plus the integral from 0 to t, and then in here goes a prime of w dw. Okay, so that's that. So, so a of t equals a of 0. It tells us the treatment tank is empty at t equals 0, so that's just 0. So it's the integral from 0 to t. And then, guys, here's a little trick. So a prime of t, we know it's rate in minus rate out. And we know that the rate in is e of t. So we can just express this as e of w minus the rate out is 645. Okay? And if you feel yourself losing concentration, just pause the video, come back to it later when your mind is more fresh. But you want to understand everything that I'm doing. Okay, so here is this. So that's what we're going to use right here. Okay, so first we need a of 0. Well, guys, they already told us that the treatment tank is empty at time t equals 0. So a of 0 equals 0. Now this here, we need a of c, and that's going to be equal to this, 0 to c, and then e of w minus 645 dw. And this will be approximately something. So in my calculator, I go math 9, 0 up to c. And then e of w is 850 plus 715 cosine. Oh, this is so much work. I actually enjoy the work, but I just feel bad for you having to follow me. Minus 645. Okay. dx. Okay, so there's that. And how do they want this? To the nearest gallon, what is the maximum amount? Okay, so they're saying here to the nearest gallon. So I guess we'll just do that. All right, so this is approximately 1637 gallons. And then for B, I'm going to do the same thing. So this will be A of B equals 0 to B minus 645. All right, and then this will be approximately. Oh, and I'll just go second enter, so I don't have to enter all that in again. And can I go up? Oops. Ah, I want to go up to the top. Why can't I do it? Don't tell me I have to. There we go. Okay, so I'll delete that. B. Okay. And then this is 1229 gallons. And then we've got to do 4. All right, so same thing. Second enter. Come on. How did I do that before? There we go. And I put a 4 up there. Okay, I hope I'm doing this right. Yes, I am. Okay, 1401. So A of 4 equals 0 to 4. Okay, so back to what they're asking. Okay, so at what time is the amount of sewage in the treatment tank greatest? And then to the nearest gallon, what is the maximum amount of sewage in the tank? Justify your answer. So, all right, so what's the greatest one? It's this right there, okay? So we'll say the amount, of sewage is greatest in the tank. I should say in the tank. The amount of sewage in the tank is greatest at T equals whatever C was. Okay, so whatever C was this. 2.3093. And what is this in? Hours. Okay. To the nearest gallon, what is the maximum? Okay. At this time, so we'll be like at this time, the maximum of sewage is this output right here. Gallons. And then we could be like this. We could say, because they do want you to justify your answer. Okay, so we'll be like C did its test above for justification. Okay, now there is just one more part to this. Take a break if you need to. For this time interval, the cost of treating the raw sewage that enters the tank at time t is this dollars per gallon. To the nearest dollar, what is the total cost of treating all the sewage that enters the tank during this time interval? Now guys, total cost. Okay, total cost. when you hear this word total, limit, derivative, or antiderivative, integral, it's this, okay? Specifically, you want to use an integral to find it. All right, total cost. So we've got to figure this out. Okay, all right, let me say this. We'll say, now I already used C, so let me say this. I guess I'll use H. Let H of T equal cost. The cost of treating the raw sewage that enters the tank is this dollars per gallon equals, okay, I see. At time T is this many dollars per gallon. Okay. Yeah. Shoot. Okay. All right. Well, all that. Okay. So, this is hard to explain. Okay. All right. Let me do this, guys. I need to just take a break because this is a long video. Let me take a break and figure out a great way to explain this. I'm going to use the units to explain it, and it's going to be great, but I just can't think. It's going to be sloppy if I just try to power through it right now. So let me gather my thoughts, and then I'll make a part 2 to this. And it won't take much longer.